Hello there, I've received a request for help with this problem, which is 6.2, number 29. If you open the textbook, of course, where it ends up in your particular homework assignment, who knows? So we're going to find a bunch of different binomial probabilities in a distribution. We're going to compute the mean and standard deviation, and then we're also going to create a histogram and comment on its shape. So let me do all of those things. I'm going to start off by viewing an example, of course. So let me make this. So we're going to use n equals 4 and p equals 0.3 for the example. So I'm going to go here to Excel and I'm just going to write n is 4, p is 0.3. Now you don't have to do this in Excel. I'm going to do it with both Excel and with a calculator just to show you how to do it either way. You could just write this on a sheet of paper for yourself. So n is equal to that, and p, which is your probability of success, is equal to that. That way I just have it for my own benefit. And then I also want x and p of x. Now remember that x can vary from 0 all the way up until n. So for our particular example, because n is 4, I'll go from 0 through 4. If n was 17, you'd go 0, 1, 2, 3, all the way up to 17. So you have in whatever x values, you have x values go from 0 all the way up to whatever your n value is. Now the first thing I want to do is I want to find the probabilities here. Now I'm going to show you this with a calculator and with Excel. With Excel, it's actually really easy. It's binom.dist. And you tell it the number of successes. Well, the number of successes is in cell D2 for me. So I'm going to say cell D2, comma, the trials. The number of trials, that's fixed. That's in cell B1 for me. But I want to give it dollar signs because I don't want that to change when I drag down the column. I want it to always be 4. My probability of success is 0.3. And again, I'm going to give that dollar signs because I don't want that to change. It's always going to be in cell B2, which is 0.3. And then cumulative means, do you want it to add up? Do you want it to start at the probability of 0 and keep accumulating? Or do you want it to just give you the probability of 0, the probability of 1? I just want that, so I'm going to say false, enter. And then I would drag down the cell, and away you have it. Now I want to prove to you that you can find these with a calculator as well, right? Since most of you will be using a calculator on an exam, for example. All right, so on the calculator, you want to go to the distribution menu and you want to find binomial. So you're looking for binomial PDF. PDF is the false one, the one where you're not accumulating. You just get the probability of that specific number. The CDF one would have been true in Excel, where you're accumulating, you're adding up probabilities as you go. So for this particular one, I only want the probability of exactly those values. So I'm going to take letter A. And I'm going to tell it my number of trials. So my number of trials was 4, that's my n value. My p was 0.3. And then you have a choice here. So let me show you what could happen. So you could type the number 0 and go down to paste, press enter, and it pasted it into your home screen. But to get it to run it, you have to press enter again. And look at that, 0.2401, which is exactly what Excel came up with. Now you could do that over and over and over. So you could go back to the distribution menu, go back to binomial PDF. There it is, 4.3, but then type in 1 and so on. And press paste, press enter, 0.4116. Now to go a little faster, you could do second enter. That brings up the last entry, or you can use your arrow keys and arrow up there to the last entry and just change the number to 2 and so on. And I can go up with the up arrow, press enter, it brings it down, and then go back in here and change it to 3. I'll do that one more time. Go up with the up arrow to highlight that binom PDF, press enter, and then go change this to 4. And there I have all of them. Now, this is a little bit slow and a little bit cumbersome. So let me just show you one more little trick here. I could go to Stat, Edit, And I'm going to clear out these old columns right here. So I'm going to make L1 and L2 clear out. Now in L1, I want to put my X values. So I want 0, 1, 2, 3, 4. And again, you fill in however many you need. You go up to where N is. All right, now over here in the L2, I wanted to put the Binompdf portion. So you can actually do this a couple ways. The easiest way is actually to stay in the Stat Edit menu, go over to L2, go up, and you can see it's asking list 2, L2, what would you like it to be? I want it to be those binomial probabilities, so I can go second, distribution, and then go to letter A, which is the Binompdf one, pick that, and say, yep, my number of trials is 4 for me, put in whatever your value is. My number or my probability of success for my example is 0.3. You can put in whatever value you like. And I'm going to leave X value blank. I'm not going to put anything in. I'm going to go down to paste and press enter. And then it pasted it in there. This is why paste is such a nice feature. It's copying and pasting literally into the calculator. And then I press enter and it runs it. Look at that. And it found all the probabilities for me. Now there's a little bit of rounding error here, but don't worry about that, right? So we've got our beautiful probabilities. Everybody's happy. There they are. Nice, huh? All right, so that's another way to find it. So you can find it with Excel very quickly. You could find it with the calculator very quickly. You could actually find it in a table form in the calculator to make it really easy for you to follow. So there's your values for the first part. Now the second part is it wants the mean and the standard deviation. So let me bring the notes up real quickly. There, towards the end of section 6.2, there are these formulas here for the mean and standard deviation of a binomial random variable. So if you know it's binomial, the value for the mean is n times p, and the value for the standard deviation is the square root of n times p times 1 minus p, also known as n times p times q. All right, so we can use that to find our mean, right? So the mean would be equal to np, which would be equal to, well, and you can just multiply it, equals this cell times this cell. Or if you like on the calculator, let me clear this out, it's 4 times 0.3, enter. There you have it, 1.2. All right, so that's the mean. The standard deviation is the square root of n times p times 1 minus p. All right, at least that's the formula for it. So the way I'm going to find that is equals square root, and then n, which is that cell, times p, which is that cell, times parentheses 1 minus p. Right? Or if you like on the calculator, square root symbol, and then n, which is 4 times 0.3 times parentheses 1 minus 0.3. Right? N times p times 1 minus p. And there you have it. So there's the mean and there's the standard deviation. So I really should move these things real quick. Hold on. There, I labeled these a little bit just to make it easier. So part A is this whole distribution. Part B right here is these two answers. Then for part C, it actually wants a histogram. And the easiest way to make a histogram is to use Excel. Of course, we can use the calculator. It's just not as strong, but I'll show you that as well. So to make a histogram, I want to draw these particular values right here. So I'm going to highlight my probabilities, including my label, because my label's not hurting anything. And I'm going to click the, oh, you can't see that. 1 second. There you go. Let's click the Insert menu. Oh, highlight, sorry. Highlight. Click the Insert menu, and you want to choose the column chart right here. And there you go. It made a column chart, as crazy as that is. So let me make this a little bit bigger so you can see. There, this is large, so I'm going to shrink this down, move it over, move it down. There we go. I don't need this menu. I don't need that title. These labels are incorrect, so I'm going to right-click and choose, let's see, select data. And I'm going to edit my horizontal axis labels, and I'm going to choose these values, 0 through 4. Make sure you don't choose the X in there, and then say OK. And now they're correct. And if you want to muck around with the colors and, whatever you'd like to do, that's fine. Technically, well, there's an argument nowadays about whether these should touch or not, but our textbook says that histogram bars should touch. So I could format the data series and lower the gap. Now I'm working on an older version of Excel here, so if you've got a newer version, it'll be slightly different, but you get the general idea. The column chart thing will still be there, and that's all you're really trying to see. Now the mean, remember, is 1.2. So now that we have this histogram drawn, we know that the mean would fall around 1.2. So let's go back to the problem and see what they want us to do. Oh, we would probably end up choosing from multiple choice. Hey, look, I had the right answers, 1.2 and 0.9. We would end up choosing a histogram based off of the there's probably some multiple choice. They'll give us a few different histograms with the mean labeled. So this would be 1.2. Now notice it's skewed right, which is not really surprising because our probability of success is lower than 0.5. So that'll tend to make a binomial distribution with a small n size, small sample size, skewed right. It has the peak on the left side and the tail over on the right.